Right, good day and welcome. I'm Mr. Simons. In this lesson, we'll learn how to draw a cubic function, given an equation with a negative a value, and we'll learn how to find all the things to put correctly. So given to us, they gave us f of x equal minus 1 over 3x cubed minus x squared plus 24x minus 5. We have to sketch the graph. So to sketch the graph, we have to find the y-intercept. We must be able to find the x-intercept. Stationary points, point of inflection, not really necessary, but yeah, it's one of those questions that's always tested. So number one, determining the y-intercept of f of x. So no matter which function we give you, if we want y-intercept, we will make x equal to 0 and substitute that into the equation. So there, f of 0 simply means wherever I see x, it became 0 cubed, 0 squared, plus 24 times 0 minus 54. All those fall away, and I'm left with negative 54. So 1 mark for negative 54. So the coordinates of my y-intercept, 0 and negative 54. Right? Then we have to determine the x-intercepts of f of x for 5 marks. So linear factors, meaning factors that divide into 54 with no remainders, 1, 2, 3, 6, 9, 18, and 54. So we're going to test all of them. You're not required to write out this part. You just have to find the value there that when we substitute in will make this equation 0. So in this case, if I take positive 3, I have 3 cubed minus 3 squared plus 24 times 3 minus 54. That gives me 27 divided by 3, negative 9. That would give me negative 9, negative 18, plus 72, minus 54, and that all equals 0. So therefore, that positive 3 now gets written as negative 3, so x minus 3 is a factor. Right, now to factorize, if you struggle with this, I've done all the ways to factorize a cubic equation in the previous lesson. Feel free to go look at it and see how to factorize. But I have x minus 3, x times negative 1 over 3x squared would give me negative 1 over 3x cubed, minus 3 times 18 would give me negative 54. If I multiply negative times negative is positive, 3 times the third is 1. So positive 1x squared, I need minus x squared. So positive 1x squared minus 2x squared, therefore there it's minus 2x. Alright? That part there we'll have to factorize via the quadratic equation. So x equal minus b plus minus square root b squared minus 4ac over 2a. My b value there is negative 2. Negative 2, my a value minus 1 over 3, and my c value 18. Bottom 2 times a, 2 times negative 1 over 3. I use my calculator to simplify. X equal minus 10,94 or x equal 4,94. 2 marks for correct factors. So my coordinates of my x values or x-intercepts, x equal 3, x equal minus 10,94 or x equal 4,94. So note, we can test this. They've done it previously where we test can you use the quadratic formula to find the other factors, right? And you're entitled in grade 12 to use it whenever you get stuck with factorization. We understand that some of you will struggle with your timetables. So those are my coordinates for my x values. Right, next up we have what we call stationary points or turning points, right? Don't get caught out with English. Sometimes they say calculate coordinates of the stationary points, and sometimes they say calculate coordinates of the turning point. Now this is new and it's taught to you in grade 12. So this question gets tested whether we're drawing or interpreting functions. Alright, so there's my equation. To get stationary points, I will always first have to find the first derivative. So first derivative of that, I'm going to say 3 times negative 1 over 3, which gives me negative 1. 3 minus 1, which gives me 2. 2 times negative 1 gives me negative 2. 2 minus 1, x to the power 1. 1 times 24 gives me 24. x there, 1 minus 1 becomes 0. Anything to the power 0, 1. So therefore the x falls away. And the first derivative of a constant will always equal 0. Alright, now we make the first derivative equal to 0. Very important, I have to show that in exam. You have to go write physically the number 0 there, as you can see, give you a mark for writing 0. Now if you factorize, minus x squared can simply be minus x times x. Factors of 24, 6 times 4 gives me 24. But if I multiply, you see 6 times negative x gives me negative 6x. 4 times x gives me 4x. Minus 6x plus 4x would give me minus 2x. Therefore, if we make this equal to 0, 4 goes over, negative x equal negative 4, or x equal 4. And there x equal negative 6. So 1 mark for the first derivative, second mark for making it equal to 0, another mark for the x values. Now very important, these values we got from the first derivative, or from this equation of the parabola, which is the first derivative. They must always go back into the original equation. So we don't substitute in there, but we go back to where we started. So I take f equal to, or x equal to 4, f4. I have minus 1 over 3, 4 cubed, minus 4 squared, plus 24 times 4, minus 54. Gives me 47,3333 going on, or 47 and 1 over 3. If I use negative 6, then negative 6 squared, negative 6 cubed, negative 6 squared, plus 24 times negative 6 minus 5. Punch that all in my calculator, I get minus 162. So my coordinates of my stationary point, 4 and 47 and a third, which can also be written as 142 over 3, or negative 6 and negative 162. So hope you follow the procedure. Whenever we want stationary points, very important you know this, because I'm going to do it under application of calculus 2. Right, when you say stationary points, we're going to find first derivative. Make it equal to 0, factorize and solve. X values back in the original equation to find the y values of my turning point. Right, let's find the point of inflection. So find the coordinates of the point of inflection of f. So here again, for point of inflection, we're first going to get first derivative. So 3 times negative 1 over 3 gives me negative 1x squared. 2 times negative 1 gives me negative 2x. 1 times 24, 24. X falls away, and that becomes 0. Point of inflection, I have to find the second derivative. So that simply means I am deriving for second time. So 2 times negative 1 gives me negative 2x. 1 times negative 2, negative 2. X falls away, and 24 becomes 0. Again, 1 mark for me writing that the second derivative equals 0. So 0 equal minus 2x minus 2. Take negative 2 over, it becomes positive 2. 2 divided by negative 2 would give me negative 1. Therefore, x equal negative 1. Right? Then we always substitute back into the original equation. Not the first derivative, not the second derivative, but back into the original equation. So there, f minus 1, punch it in, minus 1 cubed, minus 1 squared, plus 24 times negative 1, minus 54. Simplify to minus 236 over 3. So my coordinates, minus 1, minus 236 over 3, 1 mark for that. Right, so when they say point of inflection, I must get second derivative, make it equal to 0, solve for x. X go back into the original equation. That's the pattern you have to get used to. Right, now let's plot function. So note a is negative, therefore the graph goes from concave up to concave down. When a was positive, it went from concave down to concave up. Right, so there's my first x-intercept, minus 10,94 and 0. 3 and 0 and 4,94 and 0. Turning point minus 6 and minus 162, 4 and 142 over 3. Right, my point of inflection, -1 and -263 over 3. And there, my y-intercept was by, I think was 54, if I'm not mistaken. Right? So there we've plot, and if we draw all through all those points. And there's what my cubic function looks like. So hope you follow, hope you understand. Feel free to share or comment. Alright, and last question, determine the average gradient between f4 and f-6. We already found that f4, my stationary point was 142 over 3, and f-6 was -6, -162. So for average gradient, f4 minus f-6, 4 minus -6, 4 minus -6, 142 over 3 minus -162, 4 plus 6 gives me 10. Simplify, we should get 20,93. So we'll always ask for the average gradient because it's between 2 points and it's not going on the graph but through the 2 points. So hope you follow, hope you enjoy the lesson. Please share with somebody that needs the help. It would be highly appreciated. God bless. Bye.